good afternoon to the afternoon of the second day of Build. I hope you've been having a great event so far. We hope to continue this today. And with this session, my name is Jorge Palma. I'm the lead PM for Azure Kubernetes Service. And with me, we have...
And I'm Ahmed Sabbour. I'm a senior PM on the AKS team focused on the developer experience.
And so in that line, we're actually here to talk about how you can deliver apps from code to cloud with Azure Kubernetes Service. Now, why do we care? I mean, this is Build, this is a developer conference, but we care very deeply because developer velocity is in everyone's minds, a little bit like AI as well as in everyone's minds. We see more and more the importance of developer velocity for teams, for companies, for enterprises, how they take a lot from that, the ability to be faster, to be more productive, to be more agile, and how Kubernetes and AKS is making them be up to 50% faster to ship secure apps, or how it's reducing and creating more efficiencies in their IT departments. That is why we see thousands and thousands of customers running AKS to have their mission-critical applications, to host their greenfield applications. Over 94% of the Fortune 500 companies run on AKS and across all the 60-plus Azure regions, with more to be added. And they leverage a lot of our, security compliance efforts and standards to actually deliver apps securely. Moreover, even internally at Microsoft, we have a lot of our first-party teams and services relying on AKS for its infrastructure, for its services, for its experience. So from folks like the Xbox Live Services, xCloud, several of our games like Forza, to our Office Online, our Office Suite, like Microsoft Teams, or even GitHub Enterprise, and even a lot of the AI products that you've been hearing about all week through our keynotes and the different sessions run on AKS for that high scale, high reliability, and high flexibility environment. But what does then developer velocity mean for Kubernetes and for the developers using Kubernetes, Ahmed?
Yeah, I'm glad you asked this question because as much as Kubernetes is a powerful platform for managing and containerizing applications, it also comes with some challenges and complexities. For example, developers need to deal with setting up and configuring clusters, deploying and updating apps, monitoring and troubleshooting their performance, scaling, as well as delivering their features. So today, we'll be going through these stages as we see what it takes to develop these applications on Azure and on Kubernetes. And along the way, we'll show you some demos and examples of how you can use some of these services and features of Azure to improve your development workflow on Kubernetes. So we're getting started with the Azure Developer CLI. And the Azure Developer CLI became generally available at Build. And it's an open source tool that accelerates the process of building cloud services and cloud apps on Azure. It provides a lot of best practices baked into templates. And we're announcing the preview support of Azure Kubernetes Service as one of the compute hosting options. And to get started right away, I'm going to head over to the awesome AZD template repository. That's the actual name for it. This website has an official and community-contributed templates for a variety of application scenarios. You find a lot of apps in there, a lot of templates in there. So this app, we're looking to deploy it on Kubernetes, so I'll filter that list down by looking for Azure Kubernetes Service templates. And we've just published a new containerized apps on AKS template in there. Clicking on there will take us to the GitHub repo. The app, this template basically deploys the cluster with some of the pre-baked templates and pre-baked add-ons in there, like KDA and Azure Service Operator. It configures it with the monitoring components as well. And you're free, of course, to copy this application or fork this and modify it to your own needs. So to start, I'll copy the azd init command from the repo, and then I'll head over to the terminal on my machine, and I'll make a directory for this app to initiate the template in there. So running the azd init command will basically clone the repository locally and download the template, and then ask me for something called an environment. So an environment, which we'll touch upon in a few seconds, is a way to group how you deploy your applications. You can have multiple environments created, and these would reflect into different deployments onto your Azure subscription. So let's go ahead and open this up in Visual Studio Code to see what we're working with. So remember the environment. So this ends up as a folder, first of all, in your deployment there, on your file folder structure. And this .env file will start to be populated as we run the different templates and different commands for Azure Developer CLI. So the first thing we'll do here is change this to map to our application's name, which is Contoso names. And then each template comes with a set of hooks. This template is configured with pre-provisioning and pre-deployment webhooks, which basically configure your Azure subscription with the right features that are enabled for AKS and deploys any prerequisites that you have. And then the infra part of the configuration here mainly says that you're using Bicep to configure this, and you can use Terraform as well. And then for the services, this is where your application components are defined. So this is just a placeholder here, where you have a placeholder of an application called an app, and you're running this on AKS, and you're specifying where the Kubernetes manifests will end up being. Now, if you go to the infra folder, this is where all of the infrastructure is predefined. This is the template that deploys the infrastructure on Azure. So we have a resource group to group all of the things together. We have an Azure Container Registry to host the container images that are going to be built. We have an Azure Kubernetes Service cluster, obviously, as well as monitoring that is configured through the Azure Monitor Managed Service. And we have Grafana also enabled for that, which we'll show a bit later today. And finally, we're also creating a couple of identities to be used within the application for different purposes for authentication to the different Azure services that are going to be part of this app. And this is the template that's coming from GitHub, but if you have like additional functionality that you need to add, you can, of course, modify this for your organization's need. And finally, we have a bunch of output variables, and these variables are all coming out of the Bicep deployment, and all of them, once we deploy this app, will end up in the .env file, and this is how the Azure Developer CLI is actually able to modify some of the variables that you specify in the manifest files. So let's go ahead and run AZD provision. So what AZD provision does is that it will go and see, okay, what resources do you want to deploy, choose the subscription. So I'm choosing my subscription here. And I'm going to choose the location, the Azure location to deploy that in. It will run through the template to deploy all of the missing resources. So it's running an ARM deployment here with Bicep files to deploy the container registry, the log analytics workspace, and the AKS managed cluster. Obviously, I've sped this up a bit so that we don't have to wait for all of that to deploy. But if we go to the Azure portal now and open up the resource group, we have managed Grafana instance for visualization of the different metrics that we see. We have the Azure Kubernetes Service cluster that's deployed, as well as a log analytics workspace to hold the logs, and the managed identities that we created for the application to be used by the application that we have. All right, so moving on. Let's review the application. So I have the application open up in a different Visual Studio instance here. The app consists of two microservices, a backend that is written in .NET 7 in this case. It's using the Prometheus SDK, as well as the Azure Table Storage. It's using the Prometheus SDK to emit metrics from the app, and the Azure Table Storage to store the configuration, or to store the values that the app is producing. So here some, to use the Prometheus SDK, we're using the app.metrics server. So this starts the Prometheus metrics exporter, and it exposes it at the /metrics endpoint. And then there's a /names API endpoint, which is basically what the front end calls to generate those names for the app, which we'll see in a few seconds. This is using the Azure SDK for storage, so it's storing things using the Azure Stable Storage with the table client. Now the SDK is available for a lot of languages. I'm using it here for C#, but it's also available for JavaScript and Python and many of your popular programming languages out there. So this app has already been containerized, so it has a Docker file in place. And we'll see later how we can generate this. The front end is written in Node.js. I'm also using the Prometheus SDK, or Prometheus packages. It's using the Next framework and the Express framework for Node.js to deploy this app. Similarly to C#, it exposes the metrics middleware to be able to emit things like how many requests per second is this application processing right now. And it's exposing it as well on the /metrics endpoint. And it has an endpoint as well for serving the front end of the app. And you'll see here that we have two environment variables that we'll need to define. It's basically the environment variables pointing to where the backend application is. All right, so yeah, and we have a Docker file as well. To build the next framework, we need to run this npm run build to be able to run to build the application using the next framework. Great, so now that we've had a quick rundown of what the app is, if we go back to the template, so the template has a folder called source, and this is where it's a placeholder template. This is where we should copy and paste our application source code. So we'll do that right now. And basically, the template is designed in a way so that you can bring your own applications in there and do a few changes and be up and running quickly. So I don't need the placeholder app folder anymore, so let's get rid of that. And we'll need to update the azure.yaml file so that the Azure Developer CLI knows how to deploy these two new services that we added. So let's first change this app to be backend, and we'll point it to the backend service folder. We'll change the language here to be .NET, and it's still running on AKS, and the manifest folder should be the same. And then we'll add another node for the front end, and just similarly also we'll change this to front end and point it to the right folder. And yeah, we'll change this to be JavaScript. So this is great, but to actually deploy anything to Kubernetes, you need to have manifests. So using the Azure Developer extensions for AKS, I can create Kubernetes manifests using the extension. I can also use Helm or Customize. So by pointing the extension to my application source code and providing some parameters for like which port is this application going to be listening to, we're able to generate basic getting started manifest for the application to use. So what we've seen now is...
Hold on a second. So you have a template, you just drop a random app into it.
Yeah.
And then you use the AKS extension.
Yes.
Just generate the manifests all from scratch.
Yeah.
You could customize that template to have anything you want or any application you want.
Anything you want. So we're providing a basic getting started template to get you on the right path, and then you can start dropping in your applications in there.
Cool. Tell me more about that extension.
Yeah, so that extension, we're announcing a new release for that. It's on the Visual Studio Code Marketplace. And the extension is aware of your subscription context, including the AKS clusters that you have, the container registries that you have in your subscription, as well as what's running in your Kubernetes cluster, such as namespaces and services. And all this context allows it to generate the appropriate files needed to get your apps up and running. And we're announcing that we just released a new version of that in the marketplace. But it does generate, like, to the best of its knowledge, but it doesn't really have a lot of information about what your app is running. So in our case here, this app was missing some things, like it's missing some environment variables for configuration, for example.
Right.
So
does it have that, does it guess that you're using Prometheus for monitoring?
It can do that,
okay.
But we're going to actually do something else.
Oh.
Since this is, I'm sure you've heard about AI in this conference a couple of times, we're actually going to be using the GitHub Copilot chat to help us in generating these additional things that we need for this app. So The Copilot chat runs in the Visual Studio Code Insiders edition. So I've opened the application there. And in there, in my deployment, first of all, I need to change the image that is deploying, that Kubernetes is going to be running. And the way to do that is that once you run the azd deploy command and it builds your application, it drops an environment variable called service underscore the application name that you have in your application in your YAML, and then image name. So we'll be using that here. And then there are two things that we need to update in this manifest. We need first to add Prometheus scraping annotations to tell the Prometheus agent that is running on the cluster where to look for those metrics that are published on this /metrics endpoint. So I've just asked GitHub Copilot chat to give me that. So I'll go ahead and paste that in there.
Well, that saves me some time.
It did save me some time. And the second thing would be adding the environment variables that are specific to our application here. So in this case, I'm also going to ask the chat here, hey, create some environment variables for the name API service host and the name API service port that we've seen in the front-end app. So it did do that. And I'll go ahead and paste those in my manifest in the right location.
So even though the extension created kind of default manifests, you now just enrich them with Copilot to get.
Yeah, and you can keep iterating on that. You can start adding additional customizations and basically use GitHub Copilot chat to be of help here. The service.yaml is generated. That's pretty default. And this is where you've seen all of the environment variables that the Azure Developer CLI is now added to this .env file, and all of these can be used to augment the manifest and the things that we're building.
So it's one, and it's now this whole list. That's a lot.
Yeah. So the last thing is to actually get this deployed. So we'll use azd deploy. So azd deploy will now go ahead and build those different services that are part of the azure.yaml file and publish container images on the container registry, as well as deploy the applications or the manifests that it finds in the manifests folder on the Kubernetes cluster, and as well as expose the application over a service here. So let's go and open up this API or this front end by the IP. So we have a random band generator. It generates some funny names for a band, and that's good so far. But remember when we said that this application is actually storing some things in Azure Table Storage? How did we actually deploy that storage account in the Azure subscription?
All right. Can skip that.
Yeah. So this is where one of the big challenges of having and building cloud-native apps is consuming managed services and managed cloud services, such as Azure Storage, databases, queues, and caches. Because consuming these introduces some complexity in your development workflow. So for example, for Azure Table Storage, you probably need to go through several steps, like creating the resource on the Azure portal or through the Azure CLI or through ARM, and then getting the connection string and credentials and configuring your app to use them. This can be a bit of a time-consuming and error-prone, especially if you have to stamp out multiple environments of these and you have multiple teams working on that. And this is where the Azure Service Operator comes in. It's an open-source project that allows you to provision and manage Azure resources natively from the Kubernetes APIs, and we'll see what this means. So let's take a look at some of these things in the Azure Service Operator website. So ASO supports over 100 resources today and 20 resource providers. Our application is using storage. So we'll use ASO to create a storage account and deploy this along with our Kubernetes manifest that we use to deploy the app itself. So if you go back to the application source code and go to the manifests for the deployment, first of all, we'll have two environment variables for the storage account, endpoint, and secret that the backend code references. And we'll see where these are populated from. And in the Azure Resources folder, we have a storage account.yaml. So this is using the Azure Service Operator to create a resource group from Kubernetes. So we're using that to create a resource group to host a storage account as well. And then if you see it, the storage account configuration here, ASO is actually going to synchronize the secrets from Azure to Kubernetes secrets that the application can reference as environment variables. So let's look at what we have in the Kubernetes cluster. So I'll use K9s, which is a free tool to connect to Kubernetes clusters. And if we now, there's a storage account resource definition here. So we have the Contoso name storage account. This is mapped directly to the Azure storage that's deployed on the resource group. And if you go and view the secrets, in the namespace of the application, which is Contoso names in this case, we have a secret that's created with the endpoint as well as the connection keys that the application can now use. And of course, if you go to the subscription now, or the Azure portal, we'll be able to see the same definitions in there. So, George, this has been nice. This is a pretty complicated application with 2 microservices. Mm-hmm. So how does someone go ahead and start monitoring and observability on this one?
Thanks for asking. I was getting bored here, so I guess I was wondering what I was doing here anyway. So it seems like Ahmed showed us, on one hand, how to get the application with Prometheus, kind of emitting Prometheus metrics. You, together with Copilot, showed us how to get the scraping going into the deployment manifests, but where is all of this going? And so this is actually going to Azure Monitor Managed Service for Prometheus, which we're GAing now. So probably a lot of you are using Prometheus today. Maybe you're using also Grafana for visualization. Maybe you're using different tools, but they might be based on the Prometheus kind of standards that created. It's kind of the de facto standard for monitoring in the cloud native space. So we're really, really happy to make generally available this offering that is going to be managed by Azure Monitor at scale, so you get all the high available performance environments, and have that done at whatever scale you're running, which for anybody managing Prometheus in this room, probably you know how hard and complex it can become. And you have a very, very easy integration with aka. So it's a fully managed add-on. You just turn it on, and it's configured for you. This pairs, obviously, very, very nicely with the Azure Managed Grafana service that we GA'd last October. And that gives you kind of the full stack for collection, for emission, for visibility, and you can now benefit from a number of built-in dashboards, as well as community dashboards, or even your own created dashboards. What am I talking about? So let's take a quick peek. So the actual template that we deployed already had, as Ahmed showed, Prometheus add-on as part of our infrastructure and Grafana dashboards deployed. So if we just navigate to the insights blade of this cluster, you can see all the the basic metrics and monitoring that Azure Insights delivers you. But now we can actually just click that button, view Grafana. You'll see your linked Grafana instances. Again, hint, you can actually have more than one. That actually then sends you into the Grafana dashboard. And from here, again, as I mentioned, you have a number of built-in dashboards. You have the ability to add your own, to go get some from the community, and just add them here. And in our case, we went on and added a specific dashboard called the request per second dashboard that has some metrics that you might guess we're going to be using throughout this session. So you'll see our average cluster CPU and memory, the number of replicas, which is just one, very ambitious from us, and kind of the request per second of the backend and the response time, how that's playing right now, which again, nothing too surprising since we just deployed this and there's nothing happening. But there's a little bit more. We're also really, really excited. This is something we've been working on for a long time, and you'll see a lot of things in this space that we're releasing. So we are releasing a public preview of a workbook that is specifically designed for cluster optimization that is now part, by default, of Azure Monitor Container Insights. This workbook actually allows you to detect if there's, for example, a lot of liveness probe failures. So that's not something you need to build or create. It's out there for you. You can check it out. It will allow you to quickly identify if there's any anomalies with your cluster, like a lot of events, with errors or warnings. And quite interestingly, it will allow you to optimize your container limits and requests. So in a world where obviously cost and optimization is paramount and top of mind, this will actually tell you how in that little beehive that you see there, what kind of pods are actually have their requests and limits set too high, too little, so you can actually further optimize them and maximize your infrastructure. All right, let's take a look at what I'm actually talking about. Let's jump back to our cluster. We're gonna, once again, jump into now our monitoring suite, and in this case, into our workbooks blade. And right there at the center, you'll see our new cluster optimization workbook. So let's give it a spin. Once we get in, you had those three pieces, liveness probe failures. Again, cluster is just created. So what you're seeing here really is actually the bootstrap of that. So the failures are the natural, getting started pieces. But this is where you would see if, one of your containers is, going berserk in terms of failures, if anything is having an issue. In the event anomalies, you'll see all kinds of issues that are happening throughout your cluster. Again, this is pretty much just the regular events of the cluster creating, but they're already giving us some really nice information. But you can already guess that this at scale as well as in ongoing production environments. And if we take a look at our beehive for cluster optimization, we can see our front end really green. So it's probably right side. We have good requests and limits for this one. A little bit not as good our back end. But again, remember that this is just a test, and we're not really having traffic. So that's interesting, right? So what you see here on the right is actually not just what we have and what we believe this is optimized or not, but you actually see what our recommended is. So you see basically the two red bars there. Those are actually the set requests and limits. And then you see the blue and the green bar, and that's actually the green bar is the recommended requests, and the blue bar is the recommended limits. So definitely, we seem to be underutilized. We seem to be over-requesting and over-setting the limits. But is that true? So in order for us to actually know that, we need to actually have real traffic, have real data, have real users. So that's where something like Azure load testing integrated with this workbook and with our cluster can prove very useful, because that will actually tell us what the right requests and limits are for real data, real users, and real traffic. So let's take a spin at how Azure load testing, which is a very, very handy service that Azure has and integrates very easily with AKS, can help us here. So we're going to jump into our resource group, and we're going to create this from scratch. So we're going to go ahead and jump into new service, search for Azure load testing, find it right away. And again, remember we have a front end with Node, we have a back end with .NET. So we're going to go ahead and create our Contoso load tests, set the right region. We could also simulate from different regions, so you have different patterns for your application as well. It's this simple to just create in different regions and the locations for it. And once our Azure load testing is created, we can access it and get our test set up. So we're going to run a quick test. Again, you can have more advanced tests with more parameters. We're going to go ahead and get a really quick one. Again, we have our IP right there. And we're using that brand generator that Ahmed just showed you. And that's the specific IP. We're going to say, let's do some 15 users for the sake of it. And you see the duration there, 120. And you can even have ramp-up times, so you can simulate different scenarios. And here we have our Grafana dashboard on the right. So as you see that, you see, boop, immediately spikes. You see our home page immediately growing there. You see our requests per second kind of spiking all the way into higher number. But again, we're really not going to be able to do a lot, right? Because if you remember, we have a whole single replica there. So you immediately also see those requests per second go straight up down. So we're struggling badly right now. So that's really where, okay, maybe we can now go back and actually see if we actually were underutilized or overutilized. But maybe even before that, we might need to look a little bit into scaling.
Yeah.
But tell us a little bit about that.
So, I mean, scaling is, of course, important. One replica will not do, even from a high availability perspective. And sometimes you'd scale based on CPU and memory, but other times you'd like to scale on things other than those. And this is where CADA comes in. And CADA stands for the Kubernetes Event-Driven Autoscaler. And Keda is open source, and it allows you to build sustainable and cost-efficient applications with scale to 0. It can activate and deactivate your applications based on a number of metrics other than CPU and memory usage, such as messages in a Kafka topic or an Azure Service Bus queue, HTTP requests per second, response times, things that are coming from Prometheus, and many more, saving you resources and money where there's no demand, obviously, and also like giving you access to a scale-up mechanism. So let's go and see how can we do that. So we have a Keda add-on already deployed on this cluster. So we will define a scaled object, and the scaled object is Keda's way to target deployments in Kubernetes with scaling triggers. So this scaled object is using the Prometheus trigger, which is one of the built-in scalers in Keda. It's pointing at the Azure Managed Prometheus endpoint, and it's saying, okay, if the requests per second exceed 15 requests per second, please scale this up. Let's go ahead and deploy that scaler now. So using AZD deploy again, and see this in action. So once this is deployed, we'll run another load test over at the Azure load testing service.
Same dashboard?
Same dashboard. And we've sped this up a bit over like 5 minutes. So you'll see that the original one maxed out at like 40 requests per second. But now you'll see that as the requests per second increase over the threshold of 15 that we defined in the scaler, you'll see that the number of backend replicas over the right side there are now growing to hit the maximum limit that we defined in the scaler, which is 10 in this case. And you'll see that the backend requests per second are just increasing in line with the increasing number of replicas that we defined in there.
I also saw our latency decrease a little bit, which makes me happier because things are not as slow. But I did notice something, which is up until now, you've been using AZD deploy quite a lot, but that's been essentially deploying directly to the cluster, right? So that's just like doing kubectl applies essentially to the cluster. That's not how we should be doing to production, though, right?
That's right. And this is why the template that we created for AKS already has a GitHub Actions pipeline built in that you can use and optimize as well. So GitHub Actions is a powerful and flexible platform that enables you to automate your different software development pipelines from within GitHub. We've created a GitHub Actions, set of GitHub Actions for Kubernetes that integrate with AKS and can help you automate things like creating Kubernetes manifests, creating secrets for Kubernetes, and deploying different manifests through different strategies like Canary, blue-green deployments, and just basic deployments as well. So in the template, if you go back to VS Code, the template has a workflows folder, and it has the Azure dev.yaml file here. So this is the pipeline definition for GitHub Actions. So it's using the Azure Developer CLI container-based image. So it does have the AZD command baked in. It's utilizing, or it is referencing some of the environment variables for the Azure environment, which we'll see how we set those. The first action is that it logs in to the Azure subscription using AZD auth, and then it runs the same commands we've been doing. It runs AZD provision, and then for the deployment of the application itself, it runs AZD deploy. Now, this is all in one pipeline, but in reality, you might want to split this over 2 pipelines so that you separate the provisioning of the environment or for infrastructure from the deployment of your applications. So how do we actually get this deployed? So we'll run AZD pipeline config. So what this does is that it's first check, do you have a GitHub repository that you want to use as the baseline for this? Mm-hmm. I don't, so I'm going to ask it to create a new private GitHub repository to hold my application's code. So I'm going to call this Contoso names as well. And then it will connect to my Azure subscription. It will create a couple of principals and a federated identity credential to actually allow the pipeline to have access to deploy things to my Azure subscription. And it will push as well this commit. So we can, if you go now to the pipeline that on this freshly created service, or sorry, freshly created repository, you will see that the pipeline is already starting to run. It will run through that to deploy the application as well as the infrastructure that we have. All right, so I guess
Pretty cool.
we're coming to the end of this session.
Oh, no. Just hold on a second. Hold on a second. I kind of let you play around with the CLI for quite some time, and you kind of started from a containerized app already, which I already think is cheating. You already had a Docker file. So I think there's one more thing that we definitely want to mention to you folks. And a bit of a mouthful, but we were happy to kind of announce the brand new containerization and automated deployments in the Azure portal, leveraging Draft, which is a tool that we use to create the manifest, and that is the base of the VS Code extension, developer extension, to actually generate the manifest and also generates Docker files as well. So with this new ability, you can actually see everything that we just did here, but you can even start directly from source code. And in a few clicks, you can go ahead and actually have it deployed to your cluster, set up the pipeline, and do everything in one go. Moreover, we've been using IPs. So I also think that's cheating, because typically we will want to have ingress, we want to have TLS, we want to have things secure by default, we want to have DNS, all the regular things that you typically expect for applications. And so we're also quite happy to announce the integration of the portal configuration for the app routing add-on. If you're not using app routing, definitely check it out. It's our add-on to actually enable these things, from managed ingress to secure communication into DNS integration, and all of this from the portal. All right, enough with the slides. Let's actually get into what this looks like. So in a brand new cluster, so we're going to start from scratch here, right at the very end of the session. We're going to have a full empty cluster, nothing deployed in here. We're going to go into automated deployments, which is in the portal right now, and we're going to head and go and say automatically containerize and deploy my application. So we're going to go ahead and click that, and the only thing that's required here really is for you to have an application or plan to have an application. You can go ahead and give a name for your workload. You can select your repo. We're going to go with our container names front end. Remember, we have a front end and a back end. We're going to select the branch. Again, very useful, because you can create pipelines and do this for different branches. You can have dev, test branches, and release branches, or your main branch. It detects JavaScript and suggests Node.js 19, and you can pick different ones. It also detected its Node.js, and it's suggested, as you see, that we use a Docker file that exposes port 3000, because that's typical for Node. Now, the last part is you can actually go ahead and reuse a container registry that we're going to be building this Docker file and uploading to, or you can create your own. So we're going to create our own, call it Contoso names, and then give a proper name to the image instead of those automatically generated ones. Then we're going to do the same for namespace. We're going to move on to the service generation piece. And to the manifest generation piece, we're going to give a name to the namespace, and at that point, that is fully created in the deployment manifest and updated there. And we also have our service manifest right there. Again, port 3000 mapped to port 3000. Pretty happy with this so far. So we're going to have to go create, but hold on, this didn't just deploy. This actually is going to create the ACR that we defined, but then what it's actually going to do is create a pull request in our GitHub repo that we can just go ahead and see what it did. And what it did was deploy all those Docker files, all those manifests. We're not deploying anything directly. We're going to give you control over everything. No autopilot, all copilots. And we actually give you this Docker file. And if you recall from a little bit before, this is actually using Next. So we're just going to add something to our manifest, to our Docker file, which was automatically created. And you're going to add that npm run right there to add the framework. And then we're just going to commit it, put it into our pull request, straight up from GitHub, and you're going to approve it. Because we're powerful like that, then we don't need reviews. But typically, you'd want to do some reviews here. And once you actually commit this, now you have a GitHub action that will act on your pull requests, and it's kicking off. And you can guess how it was, because Ahmed, I just showed you what this does. So it actually is going to build a container, add it to ACR, and deploy those manifests that was just created into AKS. So our front end is now there being deployed. And let's do a little cooking show, because the session is ending, and let's do the back end really, really fast by following the exact same steps. Again, pretty helpful, because you can actually create individual pipelines, individual pull requests, even different teams for different services. So if this was 30 microservices, you could be doing for each one independently and at your own time. And hopefully, when I'm finished talking, we actually got the backend also deployed right now. And we can go ahead and check them. So both of them are happily deployed right now. And we can just go ahead and navigate to services and access them. Look at that. They have IPs right there. We could go ahead and access those IPs and happily access our brand generator, right? Anybody? Right? Right? Wrong? Any problems here? So as I said, we actually don't like IPs that much. So even though this is working and it's happily port 3000 with that 40 IP, that's not what we want. We want DNS, we want TLS, we want the whole package. So what we're going to do is add an ingress. Right-click, add. You can also jump into the service itself and just add your ingress from there as well. We don't have app routing installed, so we're just going to enable it. And since we're at it, we're also enabling at the same time Key Vault Secret Store, because guess what? We're going to use TLS certificates. So we're just going to go ahead. We're just going to select an ingress name. Again, Contoso names frontend seems appropriate. It's mapping automatically to the right namespace and into the right service, but we could also change it up to us. We're going to select a key vault. We could create one, of course, but we already have one created with our certificate. In this case, it's a nice wildcard that we have there. We're going to select it, and next we're going to be adding some DNS. In our case, we're going to be using Azure DNS, and we're going to select our Azure DNS zone, but you could use your own provider. You could, as you see, third-party providers, so if you already have a DNS provider, go ahead and use that. We're quite happy with Azure DNS and zone, so we're just going to add our subdomain name right here, Contoso names. Go ahead and deploy this. And if all is right, we're going to have our manifest created for us right here, fully populated. I didn't have to do any YAML whatsoever, or any CLI, and I did it all from the portal, all through pipelines, all through configuration as code, infrastructure as code, and deployment as code. So thank you so much. Yes. Yes. And now hopefully this works. But after a minute, we're actually going to get the DNS populated and updated for that IP, and we're going to get our application deployed now with DNS, HTTPS, everything configured there. So close to the end, so just to conclude, we really want to make sure that AKS is providing these bootstrapping tools for you. Instead of actually abstracting the power of Kubernetes, we want to make sure that you have Kubernetes at your fingertips, but the necessary productive tools and bootstrapping to enable you to be productive, to be successful, and to have developer velocity. We're leveraging all the breadth and depth of Azure, from Dev CLI to VS Code to the extensions and our integrations with GitHub, as well as the Azure portal to create these experiences. So again, I recommend we have a session coming up right now, actually, which is the AKS Past, Present, and Future session, where you can literally ask any questions in your minds. If you have any last-minute ones, you can submit them there. We'll answer them with our SMEs. And I definitely recommend you keep looking at the AKS sessions. We have another one as well. So after this past present one, to modernize with serverless and containers. And we had great sessions yesterday that you can check out on demand as well. So keep plugged there. And do we have any one question coming from Pubble? We do. Maybe you can take this one.
Yeah. The question is, how does AZD work with multiple services in separate repos? Is it possible to reference the infrastructure in a separate repo? Ideally, I'd like to have the app manifests in the app repo and shared infra in its own repo. So one thing is that you don't have to deploy everything at the same time. So it might very as well be that the infra is deployed by a different person, and then the app is deployed by a separate person. And the AZD has a way to refresh environments, so it can pull down environment configuration existing already, and then you can just do the developer aspect.
Nice, nice. And the second question is, are these VS extensions that do all this magic already available in the marketplace? And the answer is yes, absolutely. We just reached 1.0 on the dev extension, and I'll definitely recommend you check out the AKS extension that allows you to do troubleshooting and debugging and many other great functionality. It has Copilot integration, so go for it. And the Kubernetes extension itself. And then DevOps, which is the next question, is coming. We're looking to integrate with Azure DevOps further with all of these tools, and that should be coming in the near future. I think we're really at time right now, so I'd like to thank everyone for coming, and have a rest of a great build. Thank you very much.